Hey there, everybody. The purpose of this quiz is to get you a solution for the CDC quiz about H1N1 swine flu. We're checking to see if these clever scientists' attack would have been effective in creating an H1N1 vaccine that was effective enough. And the definition of effective enough, I got you the link right here if you want to go check it out. It has to produce antibodies in at least 70% of its recipients. So you give the person the flu vaccine. If it produces the antibodies needed, that's a check. If you give it to a bunch of people, if at least 70% or more of them get the antibodies, then we're good to go. So these folks gave it to 175 people, and 140 of them developed enough. That's a random sample. So the idea is it enough to have shown that that's enough antibodies? So let's see. Let's run the test. We got a little template here to go through. Make it a little bit larger so we can see it. Oops, that is not making it larger. We'll do it down here. That's a little clear. So we're definitely testing a proportion because it's a percentage of antibodies, that's for sure. What variable are we testing? Well, we're trying to see the percentage of people who got antibodies. Now, in some phrasing of that sentiment. Percentage of people who got enough antibodies, whatever you want. What would be enough? Well, that, as defined, was greater than 70%. That was the definition of what enough is. What is the opposite of that? Well, less than or equal to. Let's insert that symbol. Less than or equal to 70%. If you just put equals, that's fine too. But greater than 70 is definitely the claim we're testing. What are the two types of error? Okay, so a false positive would be like, ooh, our vaccine works, when it doesn't. So this would be saying that a high enough percentage got antibodies when, in fact, they didn't. So there's, if I can spell it right, when in fact they didn't. So that's red. Let's spell saying correctly, shall we? So, saying that, or maybe that not a half, saying that at least 70% got antibodies when in fact they didn't. The idea is you say your drug is working when in fact it isn't. When the type 2 error would be a false negative, saying that a high enough percentage did not get antibodies when in fact they did. So that would mean you've got a drug that works, but your data missed it. Okay? Which type is worse and why? Your call. Your call on this. Some folks are going to say crying wolf is worse because it might make a run on a useless drug that doesn't fix anything. And some folks will say a type 2 is worse because that means you have a cure for a flu and you don't release it. So it's up to you really to say what you think is worse. We're going to be using Z for sure. We're going to be using Z, and now we need the measure of standard deviation and the likelihood of that measure. And I need a TI. I think, is this a TI? Nope. I need to go we'll just bust one out right here real quick. Sorry, I should have had this loaded for you already. Let's do a new TI-83. Okay, there we go. There she is. So we need, we need stat test that is 1 prop Z. We're testing against 0.7, 70%. We saw 140 successes in 175 trials. And we're trying to see if that's enough to make us believe that more than enough people got the antibodies. Good. I think we're good to go. Oh, and there we have it. There we have it right there. We've got a Z-test statistic of positive 2.89 standard deviations. Yeah, that's good. That means something good is happening. 2.89 standard deviations. That means something significant happened. We are well over. You can even see it by the graph right there. It's not the best graph, but you're way over here. You're way over here, most likely in some curve over here. What's the p-value? You may have noticed it there. It's pretty small. It's about 2 in 1,000, which means if the vaccine were ineffective, there is a 2 in 1,000 chance that you should have gotten as extreme results as you did. It's hard to believe that. It's hard to believe. So it sure does appear that the vaccine is not ineffective. So it appears that the vaccine, is indeed producing enough antibodies in folks. Yeah, it doesn't know. Antibodies. How about antibodies? There we go. It appears that indeed the vaccine is producing enough antibodies. Now, since we got a very small p-value, it could be a false positive. It could be a false positive. In which case, if you truly want to avoid a false positive, maybe you'd want to test at even higher confidence. I mean, you could raise the confidence of this test so high that even this result would not be statistically significant. If you were running at like 99.99% confidence, you'd have to have a much, much smaller p-value. It'd have to be coming under 0.001. Or excuse me, 0.00001 if you're doing 99.99%. So nonetheless, depending on what your confidence is considered acceptable or unacceptable, that's your choice. We're going by 5%, which we do, which is pretty industry standard. So there you go. There's your flu vaccine quiz, and I hope it was helpful. See you in class.